Compute the triple integral over the region R of cosine of z over x dv. V is the volume element of the region R, and R is the region in the first octant that's below the surface z equals xy and above the triangle in the xy plane with vertices at 0, 0, pi 0, and pi pi. So this triangle, here's the xy plane, here's pi 0, 0, 0, and pi pi. So this is the line, this is the point pi pi. The coordinates are equal to each other and it goes through the origin. So this is the line y equals x. So we're going to turn this into an iterated triple integral. And let's integrate dz and then dy, because there's an x there and no y's. So it looks like the dy integral should be a little easier. And then finally dx. So x is going to go from 0 to pi. Y is going to go from 0 for any x. X will be fixed when we integrate y. So y will go from 0 up to the line, which will have y equal to x. So 0 to x. And z is going to go, it's going to be above this triangle from 0 to the height x times y. So from 0 to xy. Okay, now let's recall integrating cosine ax dx will give us 1 over a sine of ax. So that's the situation we have here, where our variable is z, and it's the x that's a constant. So the antiderivative is going to be sine of z over x, and then times 1 over the constant. The constant is 1 over x, so we just have x. And then we'll integrate dy, and then dx. And we have to plug in for z equals 0, z equals xy. So when z is equal to xy, that will give us xy over x is just going to be sine y. And when we plug in 0 for z, the sine of 0 is 0. So that's it. And then we have dy dx. Okay, integrating dy, x is a constant. The integral of sine is negative cosine. So we just have negative integral 0 to pi, integral, no. We have x cosine y. I put the negative in the front. And then we have to plug in x and 0 for y, and then integrate dx. So this is negative integral 0 to pi. If we put in x for y, we get x cosine x. And if we put in 0 for y, the cosine of 0 is 1. So we just get minus x. And if we want, we could absorb this minus back in and say it's the integral from 0 to pi of x minus x cosine x dx. Okay, the antiderivative of x is x squared over 2 minus the antiderivative of x cosine x. We'll have to figure that out. We'll put it there, and then 0 pi, and that'll give us our answer. So let's calculate the integral of x cosine of x. This is going to require integration by parts. The integral of u dv is uv minus the integral of v du. Here we want to let u equal x and dv equal cosine of x dx. Then du is dx and v is the antiderivative is sine x. So this integral is equal to uv x sine x minus the integral of v du sine x dx. The integral of sine is negative cosine, so we're going to get a plus cosine here. So let's plug this answer in here. It's x sine x, and then plus cosine x. So that minus will distribute. Let's get rid of these parentheses and just distribute that minus. So let's distribute that minus. There's minus x sine x minus cosine x. And now we have to evaluate this at pi and at 0. If we plug in pi, we get pi squared over 2 minus sine of pi is 0, so minus, and cosine of pi is negative 1, so we get minus negative 1, so that's plus 1, and then minus, plug in 0, we get 0 here, we get 0 here, and we get minus, cosine of 0 is 1, so we get minus 1, and that's plus 1, 1 plus 1 is 2, and so we get pi squared over 2 plus 2.